So thank you everyone for coming to another Sustainable Design Network discussion. I'm Saurabh Malik. I work in urban climate resilience. And about, was it 2 years ago now, I did a climate fellowship called with Terra.do, and they're a great space. I won't market them now. But during that program, they had many presenters and speakers. And one that really stood out, especially that's working in solutions, was Jenny. And I was bugging her a lot back then to get her attention, but she's very busy. And she made a brilliant talk about like climate solutions using AI. And I think AI is thrown around as a buzzword a lot, or a little too much, honestly. Like your presentation, the way you were basically using it to kind of systematically figure out what works best, where and why. It's, to me, a way to just cut through, see the signal through the noise. I would love to kick it off to you, Jennie-Marie, and introduce yourself, and then we can go into what the pie is. And we have a kind of mixed format here, which is a bit part lecture discussion and part kind of podcast casual chat. So I think that works best. So as you present, I will talk to you and dip in.
Cool. So, I like the casual chat part the best, And so I was so touched and honored when we finally connected. And it's not because I'm so busy, it's because I'm overwhelmed by email. And so I missed, and I would have been so excited to chat with you about this, because I think you're a really deep thinking, full of insights. I think you're an important brain needed for the transition. And so 2 years ago, when you first saw the Terra talk, we were still focused on cities and the built environment. And we were talking about using AI, and we were talking about climate solutions. And we were sort of, to the regular world, not the diehard climate community, which we're both a part of, we sounded a little bit bananas, because how are you going to use AI to solve climate? What is that? What do you mean AI? Thank goodness for ChatGPT and now all of the other foundational models, because now AI doesn't sound so nuts. But AI has been around for 50 years, give or take, and there's been a handful of, they call them the AI winters, and suddenly it's going to be great, and then it goes quiet. It's going to be great, and it goes quiet. But with large language models, now everybody knows about AI, which is wonderful. So we were looking at using AI, but specifically machine learning and transfer learning. And decision intelligence is the primary AI methodology that we've somewhat adapted to be able to recommend climate solutions, but do the little push towards the 80-20 to make sure that focused on the highest impact areas of challenge and solutions. So delighted to be here. And we started researching this. It actually started as a PhD thesis, like 2020, 2021. And it was, what is the 80-20? If you want to have the 80% impact, what's the 20% you can focus on? And it was also in response to, Project Drawdown and Paul Hawken, and the origin story of him saying, well, if we know where all the problems with climate change are, has anyone made a list of all the solutions? And in looking at this, we were like, well, if we know what all the solutions are, has anyone made a map of where they all need to go? Because this is happening so quickly. Even if Paris Accord was agreed 10 years ago, even if we knew about climate change, like 50 years ago, people have not gone to climate school. People do not realize that we have solutions to all of the challenges. So that was the origins of PI, was can we deliver, democratize access to what the solutions are to each of the challenges in a geo-matched way. So geo-matching was our original thesis. And then we realized that actually you can't ignore the business impact, and business will move faster the
Mm.
economy. And that'll
Yeah.
be, that's a key lever to scale. So that was really sort of the shift that we made from when you first looked at us in 23, I guess, was we
Yeah.
shifted to looking at, instead of calling it city, we'll call it space and place, and business is now included. So those are the big changes since since you
Yeah.
first met us. Yeah.
No, I think a mixed model is definitely necessary, because we talked about this a bit earlier. Be it cities and financing, it can be a bit tricky. There's always turnover with obviously representatives, and yeah, like where is that funding coming from? Is it from these kind of multilaterals? Is it from a development bank? But yeah, I think you're on the right track with that mixed approach. But one thing that also stood out to me is like having now studied urbanism and like urban climate planning, it always feels like there's just so much kind of broad stroke generalist information, which if you're new to it, then obviously you need that. But we will see these kind of graphics on LinkedIn or wherever. Trees are good for X percentage cooling, and this much this and this much that. And then they may or may not be a study that they have linked. And in theory, there is actually, well, not in theory, in reality, there's tons of studies, but they're just so, it'll be a study in China on like a park cool island effect. And then, okay, so is that generalizable? What species are we talking about? And often, like if you like speak to researchers, and I've spoken to some at C40, like even they will admit that what's lacking is long-term tracking. There's really no longitudinal study. I mean, I think the closest is, I think, Bogota in Colombia, because they've just done a massive initiative and they have studied it. But beyond that, but it's also a bit of a tropical cheat code. But beyond that, whatever initiative is being done, whether it's economic, whether it's a traffic pattern, whether it's bike lane, you don't always see that long-term kind of, what came of it. And so then it's either like a short-term thing or a marketing thing. And what stood out to me about yours was that, okay, you could kind of see what had worked and why. So like, okay, if I think you used the example of feeding seaweed to cows, this is like 2 years ago, and had worked in this X type of environment, and they had measured by how much. So now you could potentially use it here, right? Because it's a nearest neighbor type approach, data-wise.
Yeah,
But,
and it's there's a question. What about local knowledge from Naya? And that's the funny thing. So using the seaweed supplement for cows' methane reductions is an interesting one, because you can't blanketly say it'll reduce 80-90%, because if you've ever like hung out with cows or horses, or and you feed them, some of them don't like it, and they're like, no, I won't have that feed. And so you're not going to have those reductions because your cattle are not used to being fed that weird thing. So it's the local knowledge and what works in which context, why and why not, that is so critical. We need to also know why not, right? So we're not going to waste investment resources in trying things. We need to know, like, why was it okay in France to install wind farms along the coastline versus in England? Why did they say no? And the why is important, so that you're not repeating mistakes, but you're scaling and sharing what worked where,
exactly.
in this context, right? And the local knowledge is almost the most critical, because it's the local knowledge that understands, well, all you have to do is change the language around suggesting this solution. This will preserve nature, this will be nicer to live with, versus this will reduce emissions. The way, like we always talk about, solutions come in suites, and it's technology, and it's nature, and it's social, and it's financial, and it's policy. The social matters so much, because it's, why did the people say yes to this? Or why did they say no? And that's the critical knowledge, because unless the people feel that this has improved their living condition, then they're going to say no. People are not investing they're not changing in the name of climate. We're seeing that like in this era of post-aid. It has to improve my life because my life isn't good enough already. And you're asking me to make it less good in the name of global change. And it's too hard an ask.
It's too abstract. Yeah. And I think, it's not tactile enough in their day-to-day lives. So yeah, I think you're completely right about that. I feel like our chats do tend to dig in very deep, and you haven't even started kind of showing the presentation. So I will let you do that before. Yeah, I think an hour might go by before us even showing what you're doing. But yeah, keep sharing the questions because I'm on the Restream website, not on LinkedIn, so I'm being a bit of a.
So we're seeing the LinkedIn. Will there be a part about living labs? Is that like measuring what's going on the ground, what's working, feedback loops? Is that question?
I actually cannot see the questions. I'm afraid to
I can
move.
see them. You protect what you know, absolutely. And that's the whole point. You protect what you know, and local environments understand what they need, how their local systems work, what kind of food they like. If you tell them you have to eat less meat, I live in France, right? I live in Bordeaux. And I think that France only learned what vegan is, like maybe 5 years ago. And you go to a restaurant, like, do you have a vegetarian meal? And they're like, how about some fish? Like meat is so ingrained in the culture that you can't say, stop eating meat in the name of climate. But what you can say is, because France is so concerned with climate, you can say the reason that we should be eating less meat is because we are using too much land on the planet, and because, the 70% of the agricultural land that we're using on the planet is in fact being used to grow food to feed cows. So actually just go to your local butcher, maybe eat less, McDonald's, reduce your consumption and make it more of a treat. So the local context matters more than anything. I can help them.
Confirmed, and I mean, potentially depending on, so actually I'll connect two dots here. So one was that we're just kind of friends were talking literally yesterday about which country has gone, not necessarily vegan, but certainly weaned off of factory farming the most, and off of meat consumption. This is not a political point. It's just, okay, there's overproduction of meat, and oftentimes there's a lot of waste, and then there's too much land. So apparently it's the Netherlands, another thing they've done really, really well. So Amsterdam is doing donut economics, and they're like really moving towards food policy. But that is going to be a question for you later. We can save it once you kind of get into the meat of things. But pun not intended.
But Amsterdam is, I mean, Holland, but Amsterdam is kind of wild. They're almost ahead of all the climate policy. And you remember there was in France last year, there was the farmers who revolted and dumped manure on the highways and turned the local signs upside down and doing protests everywhere. And it seemed like it was the first time that it had been seen, but actually it had been done in Amsterdam, in Holland, 3 years before. And it's Europe imposing the pesticides and fertilizer laws, which seems like a great idea, but that means farmers are gonna have unpredictable yield, and they're gonna have more pests, and they're gonna have less margin, less output, and they already have such tiny margins, they can't afford any delta, and so it makes sense that they would revolt and say, no, you can't put this on us. But if you give them the solutions, biochar is a wonderful solution. It reduces water consumption by 70% and maintains yield. There's a lot of data that will show, good versus bad, but it's an indigenous old solution that replaces fertilizers and pesticides. So you have to, if you put the policy law in place, you have to back it up with, and here's the solution, and here's the grant funding, the replacement for your livelihoods. You want to make sure that you continue to do this job, so we have to replace it. So I think this is where policymakers, Europe is a great example because they're probably, the most aggressive on policy interventions. And, like there's the deforestation law that's coming into place in 2026, which means all businesses have to prove that they have no deforestation in their value chain. That's really hard, right?
Yeah.
Like, how do you track your entire value? So it's really, really hard. And they're imposing the stick, but they're not, introducing the carrot to go with it. So it's a lot of policies are not working out because they're not sort of making sure to take care of make sure that, the quality of living is not interrupted.
The practical incentives aren't there. And I'm also reminded by, you said the farmers in Netherlands went a bit crazy. I was also then thinking of the story in India. And the more I think about it, every time there's a story about farmers, it's just always them going apeshit. I think there's some mentality of farmers that I don't blame them, but yeah, I think there's something a bit extra there.
But you can't blame them, right? Because like they've been doing this for hundreds of years. This is like legacy family business passed down from generation to generation to generation, and they have their practices. And being able to predict yield, being able to predict like this year's crop and next year's crop, like that's not like new innovation. That's decades and decades and decades and passing on from, parents to children. And if suddenly there's the law that you can't do the things you did that way, plus there's climate change. There is actually unpredictable seasonal impacts. And I remember, in the small town that I lived in, like agricultural small town in France, the family that had kind of run the town, and they've been there for like 200 years, he said, I have no idea how young people, how new farmers are managing to farm now, because we cannot predict the seasons. We cannot predict the water cycles. We cannot predict the droughts. We get summer early. We get, fall early, late. Like it's totally unpredictable. So to tell them, and now you can no longer use fertilizers to ensure yield, or you can't use pesticides when there's all these new pests and there's mildew. It's not possible. They already have way too small yield.
Yeah, no, I completely agree. I'm not being anti-farmer. I was just making a bad joke. So I think we should.
You're right, though. And why wouldn't they go ape shit? Right? Like if they, on top of now having to do like online accounting and, like it's a whole new world with digital economy, they're like, what the fuck is my new life? So it's asking people to do things differently without rewarding them or compensating them.
Yeah. No, well said. I think, Leah, let's get into we're gonna circle around it. Probably in so many different ways. I think let's get into it, and then we can kind of more systematically dig into these things, just so that people have a kind of a framework of
like a baseline for what we're doing. Like the nice chit chat. So we talked about playing the new video.
Sure.
But I feel like I want to play the old video because it still stands, but at the same time, I do have a caveat. We don't have 8 years left to get to net 30 or 2030. We have 5, but we did this 3 years ago. But it's still the same mission. And the other thing that I really hate about this video is we say, and then we might save the planet. We're not going to save the planet. The planet's going to be fine without us. It's can we continue to have a habitable, environment to enjoy? Okay, so here comes the original Pi video. If I can learn to use this platform and share and do. You ready?
Yes.
Is it working?
It is. Yeah, I've made it full screen. So if you hit play, it should work.
Here we go.
We're in a race against the clock to slow global warming, stay below 1.5, and avoid the devastating consequences of climate change. Governments, industry, and financial institutions have committed to reducing emissions. They've all set their target dates for net zero. But what practical action is taking place? Can it all be done in time? Will it be enough? We don't lack the global environmental data or the knowledge of the complex problems we face. We already have all the solutions needed to address these problems. But the solutions are isolated in silos around the world. We're not learning and repeating each other's clever work. The lessons learned by these solutions must be shared, measured, and scaled. And quickly. We have 8 years left before the clock runs out and we miss our chance. We know where we need to go. We have our true north. We have all the tools we need to get there. What we urgently need is a map to guide us along the path to a sustainable and just future for all, people and planet. We need a global planetary intelligence system. We call it the Climate Pi. The Climate Pi is a shared platform that hosts hundreds of technology, social, and nature-based climate solutions that are already in operation somewhere on Earth. It calculates the real, on-the-ground impact of all of these solutions. The Climate Pi tells us what's working, what's not, and most importantly, where else high-impact solutions need to be scaled around the world. It will tell us the projected impact these solutions will have at global scale. It speeds up progress by helping us collectively map the path to sustainability. The Climate Pi will be a central point of truth for climate progress intelligence. It will harness knowledge from all of the existing authoritative data sources on human wellness, weather, air, land, water, biodiversity, energy, and waste to create a shared planetary intelligence and recommend which solutions or best practices are right for each special place on Earth. The Climate Pi is a planetary intelligence decision-making platform. It shows us the path we must take for a sustainable future, showing which solutions we need and where to have real, demonstrable impact. If we come together and follow the Climate Pi's course, we will have a chance to reach our climate targets and ultimately save our planet. To find out more about the Foundation for Planetary Intelligence and the
save our planet, right?
I think, yeah, I mean, that's a great video. I would say you have a second career in voiceover narrating.
Voiceovers? Yeah, like the path not taken. I was actually like part of a recruiting process for a CNN anchor position in my 20s, and I decided to like get married and move to Norway and have babies, but that was like the path untraveled. I would have enjoyed that immensely. Yeah.
I can see you on CNN. Yeah, that's no, but I think voice quality aside, I think overall it's just also well edited. I mean, like the graphics, like just establishing the context and the solution. So I want to. I'll let you do a little bit of the presentation, and then we can give people a kind of taster, and then we can really start diving deep.
Okay. But I mean, that was the whole point, was that we have all the intelligence, we have all the data, we know what we need to do for a sustainable future. We have the pathways. We even have the solutions, right? We have everything that we need. What we're lacking is actionable insights, and just to give a little bit of background, my last startup was a company called Alchemy, and Alchemy AI, it really wasn't AI, it was predictive analytics. And we had an agreement with the Indian government, and the mission was to support, amongst many others, in a rejuvenation project for the Ganges River. And our role in the mix of many, many other solutions was to be able to use historical data in the river to predict the impact of different investments and solutions. So for example, if you were going to invest in like 10 waste collection and management systems along the river, what would be the impact on, marine biodiversity, clarity of water, health of population, etc. And the more we dug into it, the more we realized like this is too complex. The interdependencies between the different solutions and the people and their interaction with the water, this is so much bigger. And also so many solutions that could be reused all over the planet. And they won't be found because they're in different languages, they're different cultures, it's just not, it's not being shared. And I think there were like 30,000 documents for, in support in develop, like leading up to the Paris Accord. Where do they all go? Like nobody's reading them on the bus. Like where'd they all go? Yeah. And that's the point, is that we have all the intelligence in different silos around the world. We know what to do. We have all the solutions, but it's stuck in different places. And that's what needs to come together so that we can have, what do I do here? What works here? What worked there? What's the right fit for me? And it's really human ingenuity and nature's ingenuity to put it all together so that we can start asking, like, what do we need to do? What do we do here? And then recommend it to different places with the same predictable impact. So I will now share my screen. Cut it out, you guys over there. Noise making.
Is that your office or is
No, it's my father and my good girlfriend.
Oh, okay.
And
right.
I'm trying to figure out there we go. Is that all right?
Yeah, it's great.
Okay. So we called it planetary intelligence because we have all the intelligence, right? We just need to kind of put it together. And we come up with a new tagline. What does it do on the box almost every week? We're still trying to figure out what's the way to say it. We started out as climate solution recommender, climate science, AI, but it's all about recommending suite of solutions with predictable return. So it's what's my problem, what's my context, what are my needs, and what can I do about it based on my context and constraints. Do I have the money? What are my incentives? What are my constraints? Is there time? And it needs to address adaptation, mitigation, resilience, all the above, right? I think we're a lot more focused now on adaptation in the city environment because it's already here. There's no question. And that's the challenge, right? We have all the data. We know where all the problems lie. We know how to measure them. We know the desertification of land. We know climate change means too much water, too little water. We know where the fresh water is. We know where the salt water is. We know where the demand is. I always like to remind those who aren't studying this, the whole water challenge, agriculture uses 70% of our freshwater reserves. So, your personal footprint, yes, do your best, but that's not the 80-20. The 80% is agriculture. Yeah. So what we're lacking is actionable insights. And, of all the data, what do I do? And just as a refresher for anybody who doesn't follow this aggressively, the emissions pie chart is so important. And I think too much of the media and too much of social media and too much sort of common knowledge, oh, you mustn't fly, oh, and you're very, very bad with your diesel car. The emissions pie chart is really, really critical. We use, I think concrete is 8%. Steel is 7 or 8%. Aviation is less than 3%. Cars, combustion engines, less than 5%. But materials, steel, to make cars, the use of land, the use of, and, production of waste, these are so huge. So I think that's it's really a challenge that not enough people do the homework, learn, study, and realize just where the major problems are. Let me see. But we know how to measure them, right? And one of the most I think sort of like global architectures, methodologies for studying, and this is the Stockholm Resilience Center and Dr. Johan Rockström, who's just unbelievably critical to the whole mix and everybody he works with, are the 9 planetary boundaries. And these are like the health signals and the tipping points of the planet, land use, biodiversity, ozone depletion, chemical pollution, atmospheric aerosol loading. It's very odd that Europe is warming or seems warmer, recording higher temperatures than the rest of the world, because the air is cleaning, right? They have less air pollution. So the heating impact is not, because the albedo effect is not getting through. Anyway, just it's and the heating of the oceans and acidification of oceans. Everybody's really concerned and believes it's all about plastics. Not quite. It's pollution runoff from pesticides that goes into lakes and then goes into water. So it's an interdependent system. It's not the problem. It's the mosaic of problems, and the interdependent solutions. It's very complex, and too complex for the human mind to fully assimilate and fully understand, which is why the thesis was data science will help us to figure out what are the key actions. And sustainable development goals, yes, wonderful. This is exactly what we need to do. We're so far off. But at the same time, they're not precise, they're not actionable, they're not, okay, if you want to have good health and well-being, what are the actions that will get us there? And again, in this post-aid world, it has to come back to ROI, because and do it for the good green action, take your green hat off. No, it's got to be, what's the return? And I think that's the great, huge shift that has happened in, let's say, the last year, that we can no longer influence publics and influence industry, do it for the planet needs it. No, it has to be, and here's the ROI, and here's how you will survive, and here's how to future-proof your community, your business, etc. Stop me whenever you want, right?
No, I want to let you get a nice runway going, and then I'll come in, because I think I want people to understand really like the foundations of it. Not everyone is kind of aware of kind of the basics of some of climate science, because we have a lot of people coming from built environment, and we have a lot of people coming from urbanism, and not many. I don't know how many pure climate people would be necessarily in our network. I mean, it's quite broad, but yeah, good to kind of set a foundation.
So we always go back to Maslow's hierarchy of needs and sort of the updated version based on now our current time on the planet. And this is the challenge of trying to get people, systems, businesses, cities, countries, nation states to transition towards net zero. But nobody says yes unless basic needs are met. And I think it's worth admitting out loud that we no longer, you can talk about developed and developing world, but I don't know if I have the full stats accurate, but the US, like 50% are living month to month / what they consider to be poverty. I live in France. 60% of the population are on minimum wage or less, and it goes across the board. People are not, they're not earning enough. They don't have a good enough quality of life, even in the developed, rich worlds. So how can you ask people to accept having less in the name of climate? So in any transition plan, in any adaptation plan, in any investment, you have to be looking at, are we meeting the basic needs? So in all of our recommendations and the sort of the methodology that underpins our recommendations, it's, what are the basic needs? How do you meet those in a way that actually delivers value? So, waste transformation, income introductions. We can't forget that humans will say no if you ask them to, reduce their existing status quo. But fortunately, there's a brilliant, it's an Oxford, and many will have heard of Dr. Kate Raworth. So it's a new economic system and economic methodology framework that marries the planetary boundaries, the Earth health signals, with human needs. And if you can meet all basic human needs within the planetary boundaries, then it's a livable and sustainable planet. So she refers to it as a safe and just space for humanity, which is meeting human needs within planetary boundaries. So this is something critical for everybody to understand, that there is a model, and it's an economic model, which is important because that's how we measure growth, progress, everything on the planet.
Speaking on that, I wanted to jump in with one example of this. Maybe it would help highlight it. So I read, a friend of mine sent me an article, and I think some people have probably seen this to some degree. Like, Sweden built a lot of buildings fully by wood, and I think they're starting to set records. I think they already have on the tallest building made of wood, and it's fireproofed really well, all of that. But just recently it was announced they're basically building a whole kind of neighborhood out of wood entirely. And it's a pretty big development. It's well funded. And yeah, they're trying to scale this concept up, right? Or this approach, I guess. But then I also look at the fact that Sweden is 70% forest. And, they have local access to that, and I think the type of trees they grow faster. There is obviously it's a bit like common sense that there is CO2 gain from chopping trees down, but we do need to build things. I think it's like 50% of the infrastructure cities will need hasn't been built yet. Like
75, I read today in preparing. Yeah.
I think that's what, 75 by 2050 or something like that. But so that, if that's the case and we have to build stuff, then you build it from the least carbon intensive way. So even though chopping a tree does release a lot of CO2, it's way less than concrete and steel, and concrete is like the highest.
That's
but
true.
Then how do you look at that? Like if you had that, and they have a certain natural resource abundant to them, how was the data analyze that and pitch it to someone else? Or would it just say like, oh, you know what, unless you really have a dense forest, we probably, the AI will filter out that solution?
That's such an interesting point, because humans try to simplify everything. And I think that the growing trees using wood, trees has been, for, a lot of people, the answer to everything, plant trees. But Sweden has the luxury of a population that trusts their government. Mm-hmm. And it's a small population, it's 8 million. And so they've got land mass. And nobody debates, the necessity of climate change. And they're a very wealthy country. I lived in Norway for 10 years. And Scandinavia feels like its own continent in a way. It's very different from, sorry, loud dog telling us that his dinner time is now. So, they've got so much government funding for the transition. So they're willing to fund pilots, and they're willing to try everything out. And building houses with trees or with wood is part of their culture. So it's interesting that that's just embedded the way we do things here, and same goes for Norway. And so it is a renewable resource, and it is it actually does capture carbon, and you can do like the passive houses. Those are incredibly interesting climate solutions. And this, given the stat that you gave, we have yet to build like 75% of the infrastructure that will be needed in the urban environment between now and 2050. What are we going to do? Because that's infrastructure that will live for 100 years. And so, if you look at the emissions pie chart, buildings are 43% of global emissions, and that's half embodied emissions, how we build it, steel, concrete, and how we heat and how we cool, and that's the other 50%. So it's really, really critical to look at how do we build. So I think that, it must be measured and evaluated, because there's also institution.
By the way, for the record, that was not a friend who told me that. It was my girlfriend who just texted me and said, "You just friend zoned me live on LinkedIn." So
nobody knew that it was your girlfriend who said that. So we didn't know that was friend. Yeah. So she's officially not friend zoned. She is your girlfriend.
Yeah, it's official. I'll let you continue with the presentation.
Jumping between screens and not doing the Osmos job. So this is the data science challenge of understanding what works where in which context, and what are the lookalikes that might be able to have the same suite of solutions recommended with the same predictable impact. And there's a number of interesting examples. Sudbury. So I'm originally Canadian, and Sudbury is a town in Ontario that is a mining town. And they're determined to do sustainable mining. And I think Canada and Australia are sort of at the forefront of trying to be as sustainable as possible. That's a question we'll challenge. So, what other towns look like Sudbury? And if Sudbury starts to get things right, they make investments. They say, this is how much it cost. This is the time it took. This is the impact it had. So the, mining has its key impacts, like its disturbance of biodiversity. Like it just fucks up all the land everywhere, right? Yeah. Disturbance on local community, the tailings, the pollution that introduces, the consumption of water. Like mining is incredibly intense. And if Sudbury starts to collect these lessons, where else could you recommend it? In Australia, there are other towns that works. So it's about collecting the lessons and identifying this is a data science term, but the cluster, the little group, and who are the nearest neighbor. That was a perfect data science term you use. Who else could be the same lookalike? And you remember from 2-3 years ago when you saw the first demo we used Luxor as an example to show here are the local problems that exist. Here are the solutions that can address those problems. And the point is the solutions for planet are actually the same solutions for people. So Luxor, we used it as a first demo because it's a perfect example of a MENA city, Middle East, North Africa, high density, high waste, lots of poverty, lots of none of education and messing about with natural resources. And how do we address that? And what solutions could we introduce that would be, helping with wellness of the population, like air pollution or water pollution, and collecting waste so that we can then reuse that waste, and education programs that will enable the population to sort of take it to the next level. So what are the matching contexts? In Sadirac, you see that's my little town that I lived in the countryside in France, which they're all farmers. And you can't tell them that you can't use pesticides and you have to reduce your water consumption because they won't make it out, right? And Javari it's an indigenous territory in the Amazon. That was our very, very first pilot, was understanding, and it's the size of Portugal. It's this huge, huge territory and untouched. They're not part of the modern digital world, and they suffer from illegal deforestation, illegal fishing, illegal mining. And what can you do to help reduce that and help protect them? Because you're not there to introduce new things. You just want to protect. And there are so many other areas that look just like that. Los Angeles, their big challenge was they had, I think, something like, I'm going to get the number wrong, 3,900 or 3,600 oil and gas wells. And their major challenge was, how do we take them offline? And how do we prioritize which of them are polluting the local community the most? You know, how do we figure out which of the oil and gas wells to like turn off the quickest because they are the most polluting? And that's a problem that exists in many other contexts. So, you know, we think of global north, global south as sort of distinct, but they're really not. You know, Luxor's challenge could be the very same as some, you know, huge, sad cities in Europe, you know, and the solutions that you can introduce, reduce heat impact with, you know, use the green to gray ratio, you know, green roofs all over town, white roofs all over town, reducing the heat impact, the urban heat environment. So that's the whole challenge, is to understand, like, what are the lookalikes in different contexts, heat, water, and how do you recommend a suite of solutions that will introduce wealth, health, and address like the key climate issues. Stop me if you have any questions.
No, I do. I'm actually saving him. I just want to let you explain some of the basics. I mean, I think we can maybe, I think you have another slide on the data and how you're getting it. We can maybe dig into the meat of it, right?
Yeah. So this is, you know, back to the brilliant project drawdown, which is we know where all the problems are, and we know what we need to do in each of the different key sectors to transition of buildings, industry, food, land use, etc. And the solutions are everywhere. If you start to look, there are solutions everywhere. And the Earthshot Prize is really, really something worth following. It's every year they award £1 million to 5 different sectors, you know, nature, air, oceans, climate, waste free. And then there's always like the 15 finalists. And these solutions are the ones that need to be scaled. So you know, they're brilliant. And then there's Solar Impulse, and they have like, I think they've got 2,000 now that they've like categorized, and you know, this will address that, this will address that. So we're just collecting solutions on a constant basis. And so Pi is a sustainability decision intelligence platform. It's almost like a co-pilot, if you will. And decision intelligence is both the AI methodology and also what is needed. You know, we need to be able to make intelligent decisions because we've got so many options. So it's designing profitable sustainability pathways, or adaptation, you know, or net zero, or mitigation. It's whatever's the context and constraint of the user. And we're collecting case data on proven solutions globally. And actually, generative AI has changed things for us in a rather significant way, because it allows us to go faster and be, you know, more efficient in the collection of data. So it does a really wonderful job on translation, and it does a really wonderful job on, like, you know, reducing the size and summarizing. So generative AI is quite interesting. And the whole promise, go ahead.
No, sorry, no, please finish.
And ROI and impact simulations. And I think that this is we've learned in the past year that this is the key value proposition is, you know, I'm city X or business X, and I've got Y objectives, or I don't even know what my objectives are. I have to do something. What am I supposed to do? Because I'm told I'm supposed to get to net zero, or, you know, we've got heat. What do we do? And it simulates impact, as in, if you invest in this, it'll take this amount of time to pay back. You'll have the following impacts, and here's, you know, what you will spend and time to pay back. And because it's, you know, we all need our various options. We need our short term and our least expensive and our highest win and our quickest win. So it's like our CTO always talks about the t-shirt rating, you know, small, medium, large, extra large, suite solutions. And, you know, we've collected approximately 20,000 solutions so far, but we could be collecting like 10,000 a week, because if you manage to be entering and communicating with what's happening on the ground, and you look at all of the startups, and you look at all of the solutions, and you look at all of the old ways of doing things, the solutions are everywhere. So, you know, in an ideal world, we would make this a citizen science-based, you know, two-way collecting what's going on the ground, and generative AI is going to make that easier, right? So you don't have to speak English. So you don't have to actually know what data is. You could just like take a picture or record and transcribe it, just send it in. So it's quite interesting. So this is the structure of, the knowledge stack. So a growing knowledge base of what we must do, what we can do. This is the, donut economy. This is the transition task force. This is the Paris Accord. This is like all the pathways that we understand by sector, by context, the solutions. The sectoral best practices, meaning this is what's worked where or not and why, and here's what looks like you. And then decision intelligence is allowing you to, based on your objectives, because the user knows what they need to do. You don't tell them what they must do. They have their own context and constraints. So it's enabling them to make a decision based on all of the below, like what they should be doing. And as we were talking about, solutions are in suites. It's not like just put your solar panels or just, take your plastic waste and turn it into bricks. That it's not that simple. So we've just been collecting and researching solutions forever. And one of the big questions we always get is, well, AI, that's garbage in, garbage out. We know the data that's in here, and anybody who's been working in climate, in, the science and the transition pathways, you'll recognize it. Like this library could be called Pi. It's data that we've looked at, that we understand, that it's peer reviewed. We are sharing this with the community to be able to validate, have we got it all here? What else should be here? And it's got to be an evergreen, like the knowledge needs to grow, and we need to have contributions from what's working where and what doesn't.
So speaking of this, I feel like to some degree you're about to answer it, but like just to kind of frame the rest of the talk a bit. I think, obviously, there's no disagreement on whether there's tons of data out there or not. On the other hand, there's like two things, right? One is like a random experiment, a local NGO may do in Peru on some agriculture thing. I'm just making something up. And then another thing would be, I don't know, it could be in Ghana, and it might even have been, instead of something very kind of local, it might have been something a bit more technical from like an impact hub or something. But the data wasn't collected or it wasn't shared. So in either of those cases, like how are you accessing that? My hunch is that for the Peru example, you wouldn't. And then for the one in, say, Ghana, is it about you and your team kind of reaching out to each of these kind of, literally manually, old school, and being like, hey, share your data, please? I'm talking, of course, in contexts like that aren't open libraries, right? And I think for solutions, what I was saying earlier, especially like in urban context, the long-term, functional data isn't always collected. Now the local officials and citizens would know, oh man, yeah, that, in Athens, that green walkway plan, it was shit. All the plants died. There wasn't enough water. There was too much heat. But like it's a more qualitative kind of local knowledge, not it was documented. So I don't know if you have any, like if you can explain how that process is done. Like, there's thousands of these experiments, right? Like you mentioned seaweed and feeding that to cows here, and then something else there. So
it's a really, really good question, and who's going to know like the local context is also it's not black and white, right? And just to give an interesting example of in France, President Macron, in his ambitions for reducing emissions, and this is when the yellow vests happen, he introduced a policy to put an added tax on diesel fuel, thinking that would like discourage driving. But he didn't take into account the demographics of his population, that 60% earn minimum wage, and because they're strapped for money, they live outside of cities because it's cheaper to live in the countryside. They drive diesel cars because it's cheaper, and there's not enough public transport. There's actually almost like none outside of the urban environment. So they have to drive to their work and they have to drive their kids to school. So he penalized, not meaning to, and I don't want to criticize because I think, France has been really at the forefront, but this is not understanding the user context. And that's the hardest thing of all across the board. And only the user will understand their context. So to attempt to answer your question, this is a primarily rules-based AI system. And climate knowledge, this big body at the bottom, the big chunk, that is the data that is available on what worked where and what didn't, open for peer review, but that's unstructured data. So that's podcast transcripts. And if any of you guys have listened to Outreach and Optimism, for example, or My Climate Journey, like there's so much data being produced to say, this is what worked where, this is what didn't work. Like there's tons and tons and tons of knowledge. And so that's what we've used to train sort of like the brain of Pi. And then the solutions database is a structured, like think Excel spreadsheet, where you say this solution, this location solves this problem, has been tried like this, will cost you that, etc. And this has to keep being updated. And where the real learning happens is, and I hope that I've got a slide that will take us, is when the user says, okay, I say yes, that sounds good for me. This is my decision model. You are helping me meet my objectives. And Pi will pre-populate what you should do because you're an agricultural company, or because you're a hotel, or because you're a mayor, or whatever you are. By sector, there are the 80-20, the things you must be looking at: the waste, the water, emissions, and energy costs, and the externals. This is decision intelligence, by the way, and it's called a causal decision diagram, where it breaks your decision into like a blueprint. And you can't control the externals. Like I can't control drought and flooding, but it's going to happen. And you can, you can infer that by location, climate. There's a lot of observational data that we use to infer that. And then the actions are, what can I do to achieve my objectives? And so this is the under the hood intelligence that Pi, recommends. And then the learning is, who said yes to which decision in which context? So the answer to your question is, we will learn. That's why it's net zero by 2050. This is a very complex endeavor to completely re-engineer the systems. It took the world 100 years to get to GAAP, the generally agreed accounting principles, measure progress by money. 100 years, right? And now we're going to introduce people and planet. How do you measure those things? So it's very, very complicated. So we don't think that we're going to have the answer. And thank goodness there are so many just thought leaders, people working on this, brains, willing to like throw their bodies over the train tracks like yourself. And we need to pull all that together. We need to like harness all of the intelligence that's been created, like the 30,000 documents for Paris Accord. All that needs to come into one place, which is why it's called planetary intelligence, because all the knowledge is all over. We just need to somehow, create a platform that brings it all together and allows us to like understand what to do. So we're going to be learning. There is we don't know how to go down into the collection of what's working where, and we don't know how to fully scale because there's so much noise. But that's the goal, is to learn which user context chooses which decision model in which context with which outcomes. So the real machine learning will happen at the top of the pyramid, which is, what did you choose? What were your objectives? And what were the outcomes that we can then recommend it to, the different context signals. Every business, every mission, you always have like the hardest questions that it takes you forever to answer. So this is one of those eternal questions, is how do you identify and how do you tag, like describe the user context?
Right. So that's like kind of user testing and then prediction of it. But just to to go back a bit, so the Excel sheet with all the specific examples, those are just manual added. The AI isn't scanning and adding.
So
That's not what the AI.
we're starting to use AI to try and do it more efficiently. Like we've learned over the years what's really inefficient. Like the first 400 solutions that we entered into the database, they were manually researched, with like climate degree scientists, like understanding and manually researching. 400 took us 4 months. That's not efficient, right? And then we looked at so the Solar Impulse Foundation, which is a really interesting, like it's apples to apples. And I've been one of their expert evaluators for some years, so I know what the data set looks like. Mm-hmm. And it's a data set that says, this is what it costs. This is the impact, the results of using this product, solution, intervention. And, like you could hit enter here and buy. So that's efficient and consistent data. But then what are you going to do about, the town in like Kenya that in my notes, I have this, I'm just so amazed with this, like 500,000 smallholder farms are using drought resistant seeds. And like, what will be the impact of that? Are they all going to be like into their phone recording, well, it worked out really well, like my yield was good, or only 20% of them actually like sprouted and grew? Like, how do you collect that data? That's something that we're going to be learning. The idea would be crowdsourcing those experiences, right?
So far, what do you feel would work in that type of department, like with that department in that situation? So these farmers use it. Best, optimal scenario is that they collect systematically and publish. That wouldn't necessarily be the case. So then, would you crowdsource? Would you send someone, like fly them out locally, and like what seems to have worked well so far?
So there's always like the chicken and egg challenge, and we have found that actually taking it from the solutions perspective, which is why we, started looking at businesses as well. If you take it from Unilever, they introduced, I'm checking my notes to make sure I get this one. They introduced drip irrigation for tea crops and heat tolerant varieties of seeds to their smallholder farmers. And they saw that it was 30% increase in yield. So that's aggregate data to understand, heat resistant seeds, drip irrigation, and a large enough data set to be able to measure output. But looking at each individual one, too hard to get like a sample data set. So we're finding, where can you find the critical mass data sources? And there are businesses and cities and countries that are, focused on programs, and it's the program that delivers the data and the results, and they publish them. So maybe through C40 or through CDP or through their sustainability reports as well. And so we're looking at how to aggregate that data, because otherwise it's not, we can't do the measuring. We need to take the measurements that are being done on the ground. But again, we are not old, as we are still early stage. So maybe maybe there will be a more efficient way to do this, that you can go down deeper and learn the lessons that, one farmer figured out, oh, I know how to get rid of that mildew. And I used, I don't know, there's a hilarious, he's brilliant, vineyard operator here in France who will use like female hormones of worms to distract the male worms to go off the land. That's the kind of lesson that needs to be shared, because that's regenerative agriculture. That's, bio-identical agriculture, which is way better than, organic. Organic has like 100 chemicals that are allowed. So these are the lessons that need to be shared and scaled.
Interesting. And firstly, thank you for explaining about that. Secondly, you mentioned, these kind of, I don't know if I heard you correctly, but you mentioned these 30,000, reports in IPCC. Was your AI trained on a lot of this? Was it fed this to understand, or?
So no, right? Because you don't need all the data. You need the right data. So the 30,000 reports fed what was the final outcome of the IPCC and the Paris Accord and the transition pathways. So that was call it the metadata, call it the summary. And so actually, we don't need all the data. We just need the summary so that you can say, this is the pathways, these are the big signals, here's the signals through the noise. So we're trying as best we can in the name of efficiency and specifically energy and data efficiency to just take signals through the noise. So there's a lot of, we always say minds and machines, there's a lot of minds involved in this to make the machines smarter.
Yes. I think what would be interesting with, now that we have a good foundation, you've explained the methodology a bit, would be good to maybe see it, like how it kind of works. I think you had one of those things to show us.
Indeed, like the actual pipe.
Yes.
Okay, so this is Pi's platform, and it's all, according to planetary boundaries, according to donut economy, according to like the health signals of the planet. This is the macro view, and it attempts to look at the micro view. So there's two ways to interact with the platform. One is the local context, and we'll just use the Luxor example because, that's so interesting to figure out how do you use the people problems, the economic problems, and turn them into climate solutions. So you choose your location, your city, and you can also design, here's the geographic area, space and place. And you choose the solution, the challenge that, is of greatest impact. And in our next version, it's going to tell you which ones are the major ones. So in this case, high waste generation is sort of my favorite. But, you can just sort of choose with exposure to drought, soil degradation, agricultural drainage into the Nile. And, can
I just ask you something? What do you mean by the major ones? Because I see it says impact is high, moderate, low. You mean something separate from that, or?
Yeah, well, so impact across the key metrics. So two key metrics that we keep in is the people on the planet, emissions, and human wellness. And then you have socioeconomic factors into it. So air pollution is the highest cost in health, which means economic cost to government. So, and this is to be evolved. We're not with authorities saying this is like OECD data that says, this is the highest impact problem, but, with solutions that can address it. So, we choose whatever, high waste generation or agriculture drainage into the Nile, let's say.
So OECD said that air pollution is from all the environmental urban issues, that's the highest impact to health.
It's the most deaths per year by climate impact comes from air pollution. And the majority fossil fuel consumption.
Okay, interesting. I always thought it was heat, but I guess that's more. I mean, I don't know how they categorize these things because that might have been as a heat, a climate disaster or hazard, rather than just a day-to-day, everyday lingering effect. So I guess that does.
I think heat is newer, right? So heat, we have so quickly warmed the planet, and we already hit 1.5, right?
Yeah.
We were supposed to halve the emissions by 2030. We're so far, from our targets that the heating is catching everybody off guard because climate change was supposed to be long term. So there are many areas of the world that are used to heat, and then there's so many that are not. And the deaths from heat, I think you quoted the other day, it was like 200 deaths from the heat wave 2 weeks ago.
2,300, I believe. It was at least 2,000 in this recent European heat wave.
Yeah. So and those are new, because Europe they don't have air conditioning the same way that North America does. They're not prepared for the heat. They have historical buildings that are used to the buildings taking care of heat inside, but they're not used to the outside stuff. So they're not ready to make sure that they're not outside in the hot moments, or they're not ready for it. But air pollution, there's a lot of data on, the highest polluted countries and economies. China had a lot. There's a wonderful podcast. I'll share it with you at some point if you're interested. But the story of how they addressed the pollution and the reduction in deaths, and same goes for India, although they haven't achieved it yet. But there's air pollution is the largest cause of death in climate impacts. Yeah. Oh, we're sounding so miserable, not talking about the solutions, about the dramas.
No, I mean, you have to state the problem to get the solution, right?
That's it.
This screen is very interesting because then you have, this is one of those kind of cost benefit situations. So, I mean, this is cost and time scale benefit combined, right? So what does a decision maker do? Do they do the cheapest thing, but then it takes 12 months, or moderate thing like river pollution monitoring that takes 6 months, or they just spend big money on waste collection?
So I think we're not at the best user experience yet. This is the version that we want to offer for free to local government, to local communities. They can just make decisions. But the the recommendations of here's what you should do, that's a little bit smarter. And actually, the arrival of agentic AI has kind of removed all of the need to have these dashboards and walk through the process, that you can talk to it. You can just say, here's who I am. Here's what my challenges are. What should I do? So we're working, this is 2023 first version. And we're working now to offer this as an agent, because this is just too, how do I know what to choose? Okay, I'll try the river pollution. Okay, tell me what I can do, and tell me, what will be my predicted impact. I'm going to compare, my problem was high waste. My local solutions, I chose the cheapest one I could find, citizen-driven waste collection, and, what predicted impact can I expect? So this is kind of more involved than users want anymore. So our next way to make decisions is original agent. I think we developed this in 23, 24, and it has much to be advanced. We're coming out with another version now, but it's walking you through, who are you? What's your problem? What do we do? Oh, it's summer, so tell me about the heat island. And of course, she should not be saying, I'm putting together your causal decision model. I made our lead developer turn her voice off because it was so annoying. So this is not the right experience. But the idea is how do we learn what the user actually wants? Who are you? Where are you? What is your context and constraints? Yeah. So, and this is the decision intelligence model, which we looked at a minute ago, which is breaking your decision into, these are my objectives. Intermediates are, what can I measure to understand my progress, my impact, and what are the actions that I need to take? And as you can see, green roof, green roof, green roof. Yeah. So you can either say, great, I'm going to continue with that decision, or you can say, that was silly, give me a new one. And she'll give you a new version. She doesn't have to be a woman. She can be whatever you like. We talked about making it a little planet, or calling it Gaia. You're always evolving.
Firstly, you just roasted your lead developer's voice. That was
he is. It's not his voice. This was before multimodal AI became a thing, and he was so excited. And I think he he was ahead of everybody. He's absolutely brilliant. But we haven't figured it out. So, the experience is not awesome. So you say, yes, thank you very much. I accept the recommendation of the decision. Like, here's how I'm going to do heat. Here's how I'm going to do whatever you decided. And this is the tracking my progress and all the things I'm doing. I'm using the city demo dashboard. So this is, the many, many times City X has made a decision and said, yes, thank you very much. I'm going to do 100% renewable energy in municipal operations. That's obviously France and Europe. And like, what are the solutions that are going to help me get there? Yeah. And, how can I expect the results to progress? And going back to your question of how do you measure what's working where in which context, well-being, emissions, and the key metrics, water, energy, waste. Health of nature would be the CO2 sequestration. And circularity, meaning as little waste as possible, because we know that actually we should stop making new. We could just make from what we already have. Yeah. Right.
So I wanted to jump in because I think at this point, at least for me, I definitely get how you've explained all of the methodology and stuff. But for that visual that you were just showing, it recommended green roofs. So this is like a semi what if scenario, but I remember when we were working in Athens, one of the issues was that green roofs were really difficult to implement because the buildings kind of structural engineering, which were built, decades ago, couldn't handle the weight. And really, even the weight aside, because water is heavy when you water plants on a rooftop, and then there's obviously the soil weight, but there's a lot of leakage as well. And they had test driven it at some schools as pilots, and they didn't go well. And then scaling it across the city was imagine doing that poorly, and then how many disasters could happen. So could obviously the user would say, hey, my city can't do green roofs, the buildings suck. That's the short version. But then could they say, oh, maybe an engineer comes in from the city and goes, okay, 30% of the stock could do this. The rest cannot take load over X, kg or tons, whatever. And then can you recommend which plants and which type of soil? Because we spoke to another, I forget there's a cultural center by Renzo Piano. I forget the name of it. It's on slightly outside of Athens, and it's a massive, kind of, Starchitect building. Looks like a weird spaceship. It's not really central, but what was amazing about it was some of the green rooftop designs and the community culture event aspect. Putting that one aside, the green part, one of the guy, I forget his exact role, but yeah, he maintained all the kind of landscape and greenery there. He said that there are plants that don't take that much soil depth and that much water. So is the idea to be able to get it to that degree? And that feeds into a kind of joint question is, does your system scan all the ResearchGate and all these papers that will because some of these PhD types, they will go into minutia of every species and they're going to con to all these PhDs doing too many studies that no one reads, but there's a lot of data out there. I suppose an AI can make better use of it than the average person reading it.
Absolutely, and that's why next version will be agentic, because if you make the recommendation and user says, no, it's not going to work, then you can say why. Tell us why. And that's the data collection. It doesn't work here because, the roof structure cannot support the weight. Then it can go lightweight, so that's why machine learning is so interesting, is because the more data you collect, the smarter the machine gets. So, and now we'll understand, Athens, roof weight, no to green roofs. What's the alternative? So the recommendation would be go white roofs, because painting roof white is actually even more cooling for the building than green roofs.
Yeah.
And if it's a yes, then the understanding of in which context they made that decision and said yes, that is the machine learning. So attempting to collect as little of the the noise data. We don't need all of that, just the abstract, just the what worked where and which combination, and the human understanding of it. Because it isn't just science and engineering. It's not just numeric data. It's people thought that was really ugly. It matters,
Yeah. Would it save that kind of prompt and go, oh, okay, X users reported this type of qualitative opinion on this solution?
So this is where I'm resharing my screen, I think. This is where we're attempting to be really, really efficient in our what data we capture and in which format, right? And the format is what matters the most of all. So if you say that the learning happens at the top of the pyramid, what we want to learn is, that was a screenshot of the new agent coming. We want to capture what were my objectives, who am I, meeting the user who they are, and what did they say yes to? So if they said no thank you to your green roofs, why? And so that's why agentic AI is interesting, because you can ask what, you said no to this, what was the problem? Right? And then you understand the signal is it's because the building, the roof structure can't support.
Yeah. Sorry, would you mind going back to that? I didn't enable the screen thing. Okay, here we go. There we go. PyBot, okay. And okay. So yeah, I guess it will sort of learn and adapt over time. But did you say it does scan research papers on the built environment? I mean,
Indeed. But so there's a combination of what it's going to be what it has looked at, which is sorry, I don't know which direction I'm going in. Looking at the example of all of the climate science documents that went into Paris Accord. That's what you must do, what the pathways are. This sector has to, aviation, sustainable aviation fuel, you must reduce that, the fuel is your highest impact. Agriculture, reduce the water, reduce the pollution and the messing about with the soil, measure your carbon content of the soil. What's your 80-20? Look at that key. And so that's the, pathways, methodologies, science. We don't think that there's error, but what we'll learn. And then there's the local context, what I chose, what works, and historical data of case studies. So an interesting example, put a tax on diesel fuel. We know that didn't work, and it was for demographic reasons. Or Lego. Lego came out with a declaration in 2021 or 2 and said, we're going to make all of our plastics, recycled plastics for all of our toys and manufacturing by 2025. And that was their ambition, but they learned that that doesn't work and there's the important lesson is because the type of plastics was too difficult to get their hands on because of their supply chain, because of the durability, because of the safety, all those reasons, whatever it was. Why didn't it work? And then following on, what did you choose instead? What were how did you mitigate? How did you resolve that challenge? So these are the things we need to learn. Yeah. And because we now have the NDCs, the nationally determined contributions, the COP countries say, what is my report? And cities are reporting to CDP, and companies are reporting on their impacts. we're starting to get like, these are our ambitions. And then you cross that with, here's what climate science says we need to do. And here's what planetary boundaries say is going on right now. And these are the health signals of the planet. And then we understand, Maslow's hierarchy of needs, what people need. Yeah. Then you have your sort of like your methodology and your framework for what is now. And what do we think we're going to see? And then you have your observation, your observation data, your emissions by gas, by source observation. You have your green to gray ratio, your low orbit satellite image, observation. This is too complex for the human mind. However committed, it's too much to be able to process and understand the interdependencies. So our theory is, if we can create a blueprint of a decision, what are the key climate things? What are the actions? How do we measure? And why did you what did you want to do? Mm-hmm. This is our theory of change. So if we can capture the context of a decision, my objectives, the actions that I decided were okay, what results I got, what were the externals? I have extreme heat. We're, a coastal city, so we're going to see floods rising. We have droughts. Like, those are things that you can infer. You can use external data to say this is your context, but what we can't tell them. Well, you guys don't like to eat. I'm just going to make any, like, you guys don't like eggs. Only the local context really understands. Yeah. How do we live? Like, what does normal look like to us?
Yeah, thanks for explaining that kind of the scope of that. So then, because I know when I ask like GPT, because obviously it has a general knowledge data set, and then everything else, especially for newer like news and events, it scans. But then even for research papers, I don't know what because it's fed to the internet, but at the same time, when I've asked it, and it could be something really random, like what's the highest quality rated dark chocolate, or it could be what does research show is the best implementation of a green roof, and it still needs to scan a bit, because not all of this, and I don't just mean for like very new research, even for older research. So I'm in your context, because you're not a broad use AI, since you're focused. Does yours also not need to save that? It can just scan it when it needs to, or will you save like the 20 studies on green roofs?
So this diagram is informs so much. Like the ChatGPT or Grok or all of these other foundational models, and we don't know what's going to be the best and the smartest. But I like Grok is an interesting example, because Grok will, of course, have been trained on X/Twitter data. And that will be all the screaming and yelling of the shaming of the green one. It'll be all of the wrong and the right. And they're getting smarter and smarter at understanding how to, how to choose the best output. But they will take into account factors that we know from climate world should not be in there. So, for example, the personal carbon footprint, and this is an extremely unproductive thing to put on populations. It's about your personal carbon footprint. If every human being on the planet lived 100% carbon neutral life, which, by the way, is not possible. If you look at your desk, there's carbon everywhere. We are a carbon economy. That would only mitigate 30% of global emissions. But it was a PR campaign by one of the very clever oil and gas companies, and they were trying to distract from their actual impact and emissions. And so they came up with this personal carbon footprint, and it was brilliant. It was like the tobacco. Smoking is very safe, and so there's so much green shaming and you are bad. You drive old cars and you take planes, instead of focused on the highest impact areas, lands, food waste, steel and concrete, like the big systemic changes. And so this is why, we wanted a foundational model to enable the machine to read and write, see and draw and do all of that and create. But we want, very, very strict rules-based, like we want curated data to be able to make sure that it's recommending, first and foremost, what are the waste transformation solutions? Like, don't make new, reuse, like take like plastic waste and turn it into like diesel, or take, CO2 waste gas and turn it into like, makeup and fuel and plastics. Like reusing waste is so valuable, because then you're not making new things and you're not creating more waste in landfills, and you're not like, recycling is not actually an answer. It's like 12% in Europe and North America that's actually recycled. So waste reuse and nature-based solutions, like, to cool the city, first go green to gray ratio and put green everywhere. Bordeaux, I saw that they just installed something like, what was I made a note of it, but since 2020, something like an enormous amount of introducing new green into the city, because it will, if you just go like between a forest and a city in the same day, in the same time, it's something like 5, 10, 15 degrees cooler in the forest, because it's nature's air conditioning. It's natural air conditioning is the green, right?
So do you, I think I think maybe we should start taking some questions. I don't know if
indeed, we're going on like an hour and 40 minutes here, and I hope we managed to.
Yeah, one of my friends had a question. She's from like a tech AI background. She's asking, if you have access to a non-public data set and you connect it to your agent, does it violate copyright? And if so, then are you only allowed to use public data, or is it, for all private, is it, per case permission?
So that's a really, really, really good question, and I'm fooling around with my screen, which is not connecting properly to my computer at the moment. So this is really, really, really curated data and collected before generative AI came out. It's still being collected, and we're in Europe, so anticipating the heaviest of huge laws. So, we've made lists, and we can point to everything that has been used to train this AI. And we're expecting to ask permission, and have been doing so, about use of authors. Like these books, we bought the books, and in many cases have asked the author, are you comfortable? Can we use this? What do you think of this? And a lot of the data is behind paywalls. Like you have to actually like subscribe to use the data. So we're expecting to be hit really, really hard by laws, and to have a conversation about how we trained, what was the data. Take the Pepsi challenge with our data. That's an old people reference.
Okay. Do you have access to, thank you for answering that. Do you have access to the other LinkedIn questions?
So, at its core, a description of a circular economy. Yes, exactly. And I think circular economy, this is from Dirk Locke. And I mean, circular economy is kind of like almost lost its dazzle, because it's been said too much. But that's what we do need to do, is we need to look at our waste streams, look at what are our waste outputs and what are our feedstock inputs. Like plastic waste, bio waste. How do we turn that into new product? Even pollution waste is remarkable. Like CO2 waste gas, you can make diamonds out of CO2 waste gas. So it will be very interesting to watch the tariffs and the restrictions and prices going up, and new order of things, because it's better if we don't buy new. It's
Hmm.
better if we use what we already have. So you're right. Yes, circular economy. But again, we're not the only ones addressing this. The climate community is huge. The solutions are everywhere. We're just trying to help assemble and create a single dedicated AI that just does this. But it'll have to have the signals from socioeconomic and natural resources and understanding, where markets are going. Because despite, anger about ESG and blah, blah, blah in public markets, they are not backing down. There is no question whether or not the insurance industry is worried about stranded assets. And cities have assets. Buildings are assets. So whether or not it's popular or people are interested in that as a reporting scheme, it's already embedded in the programmatic, financial systems. So it's, we need to be looking at what do we have, what are our problems, what are our resources, and waste is a resource. And, like desalination, you could take the saline, extract it, and you can turn that into products, into minerals. So, I mean, there's so many solutions. It's wild.
Hmm.
Growling dog, you're waiting for your dinner.
All right, yeah, let's do maybe like two more, and then the dog can.
Okay. Let me see. Is this from Laurent Bio? Laurent, I'm seeing it. How do you balance planetary needs with individual quality of life? Very complex. Who says yes to what, right? Like you can't enforce if people won't say yes. And so the balance of individual quality of life, they have to think that this is an improvement on their life, right? Nobody's willing to sacrifice in the name of climate if they don't have enough. And that's when you go back to Maslow's hierarchy of needs, regardless of where you are on the planet, if you don't have a safe home, you don't have energy, don't have food, if you don't have human basic needs, you're not going to say yes to some climate story. No, go, take your climate crap elsewhere, governments. I need a home. I need food. I need energy. I need safety. I need security. I need community. I need access to education. It's only once those needs are met that solutions start to be adopted. So when you recommend solutions, it has to take into account improving the human condition, or you're going to get, manure all over your highways, like in Holland and in France. When you tell the farmers who already can't make enough money to pay themselves, have the staff they need, it's already too hard. So you tell them that it's going to be harder, and they're like, no, thank you. So.
Should we do one more?
There's so many good ones. There's so many good ones. I don't know how to choose.
I wish I could help you. Unfortunately, I'm in the wrong interface. I should have just started it from LinkedIn, but now I'm afraid to leave it now. So.
Oh, well, so Mahaley, I'm sorry if I'm saying your name wrong. So several messages here, but we can work ourselves into oblivion trying to get marine areas and species protected. But if those protections aren't enforced, nothing really changes. So this is a really huge challenge, right? So enforcement. Who's enforcing? Like there's been really interesting and far-reaching commitments by, through the UN process, like EU enforcing end of deforestation in supply chains for large companies. So that regulatory enforcement, EU uses the stick, and then North America, Anglo world uses the carrot, but there is no actual enforcement. So this is why business public markets is an interesting focus because they are punished by stock prices. They are punished by customers don't buy their products anymore. They are punished by investors say no. They are punished, like the public is shamed, and that makes them do better. So business is a really important lever because they're forced to do better because, financially, and they can't hire new people. There's like a bottom layer, like new employees coming in from university, and this generation saying, no, not unless you have, your sustainability roadmap and we know you're going to be a good actor. So unfortunately, the way the world is measured, success, progress is currently financial. That means businesses are the highest incentivized, and countries will be incentivized when it starts to become huge risk. Like this is no longer insurable. This is no longer, like there is just no more fresh water, so it's too expensive, and the population revolts and puts manure all over your streets. So it's very, very difficult because the Paris Accord was voluntary, right? Only the UK that I know of actually entered it into law, net zero by 2050. But look at, next potential in line is looking to roll it back. So it's very complex.
Well, I think we are well.
Oh.
Yeah. And I think, when two chatty people get into it, and I think you also just are very knowledgeable. So I think we tend to, these conversations just flow. And I also realized that we didn't really...
We didn't go into some of the examples, right?
Examples, but also we didn't get to really go into your background and how you got to where you are. So I don't know if you want to do that now in reverse order since we got so deep. Right?
Everybody has their climate moment. If you're working in this, you have that moment where you're like, this is the only thing that matters. And mine was 2019 October, and I was giving a presentation in Monaco about my last company that was doing the project with the Ganges River. And I was on stage with Céline Cousteau, granddaughter of Jacques Cousteau, and another woman, I don't remember her name, but she was covering the Sahel territory and the water stress. And at the time I was like this, like techie person who hadn't really been paying attention. And I was listening like, oh, that's too bad. And then listening to Celine, I'm like, oh, that's too bad. And talking about UN SDG 6, but not really, like, it wasn't entering my soul. And then I went to have coffee with Celine afterwards, as just as a chit chat. And she told me that 4% of the world's population are the stewards of 80% of the population. And, that means that it's indigenous people who know how to manage the land. They know how to prevent forest fires. They know how to do intercropping and regenerative agriculture. Like, they've been managing the land forever. And us rats of modern world, of technology world, of post, Milton Friedman, where the purpose of business is to make money, we think that we're so smart, but actually no, like, it's, nature is the most efficient system on the planet, the only efficient system, and humans are the only species on the planet that are not at 100% employment. So we got a lot to learn, but the indigenous populations, they've been sharing that knowledge. So I don't know what happened in that moment where I was just like, wait a second, does anyone know this? Of course, as if I'm the first person. And thinking, okay, if we have to get to 2050, net zero by 2050, there's no way that us foolish humans can get there unless we do it all, the shifts of the systems between the next decade till 2030. And I thought, okay, I think that this is a data science challenge. I know we have all the knowledge, and my brain just went down the rabbit hole, never to come back. And I tanked our last company and spent all the R&D resources on developing Pi, because we learned that you can predict the output and the impact of an investment in, restoring natural resources. And so we need to scale these solutions. There's clever people in France working on water system prediction from, the groundwaters all the way to the tap. but they're doing it in French. They're not sharing it. It's got to be shared, and that's the challenge. Is like the cultural shifts and everything's stuck in silos. So that's how I got here. I've always been in data science, trying to understand like the deep blue ocean of data. How do we extract insights? And I come from like the DNS world, the domain name system, which is like names and numbers of the internet. And how do we understand and make decisions based on ubiquitous data? And so I just went down the rabbit hole, never to be seen again. Yeah.
Well, thank you for explaining your journey, and explaining, that kind of climate aha moment. I hope other people have that too, regardless of your background. And like lovely chatting with you. I hope Pi keeps taking off, and I hope, maybe, I don't know if you already applied to Earthshot, but maybe you should. And I hope, we get these solutions where they need to be. So I hope everyone enjoyed the talk, and I will let Jenny go to feed her dog before it eats the family.
I heard that friend and father actually fed him, or he'd still be bugging us.
Okay, fair, but I don't want you to keep neglecting your whole family.
It's been lovely. Thank you so much for inviting us and for taking this time. And and I'm very, very happy to be in touch. And so please, do reach out on LinkedIn. I'd love to follow this conversation, and I missed tons of these questions. So if I didn't get to you, which is most of you, feel free to send me them on LinkedIn in a message, and I'd love to continue this conversation.
Yeah, and give Jenny and her Pi channel a follow, and you can give us a follow. Mine is right there, and this is the SDN page. And thanks for coming by. I'll let you go, Jenny, and I'm gonna now switch to LinkedIn and maybe try taking some questions if people are still hanging out. I have no idea.
All right.
So thanks.
Thank you so much. Speak to you soon.
See you. Bye.
Bye, everyone.